Okay, complex numbers. See how you get the joke? There's a lot of good math jokes. If it's not imaginary, it's real, right? Okay, so we did stuff like this last time. I times 2 plus 3i, and you were supposed to multiply it out and know how to simplify it. Let's see if you remember. Give it a shot. And there's this critical little step at the end that some people are going to forget. Give it your best shot. Compare it to the kid next to you. See if you got the same thing. Don't be shy. Talk to the kid next to you. All right, here's the minor league answer. 2i plus 3i squared. And the problem with that one is that they didn't know that I squared is equal to what? -1. And so then -1 times the 3. Final answer, 2i minus 3. Also minor league. Because do you remember what that's supposed to actually be? -3 plus 2i. If you never caught that, the real part is supposed to be first, and the imaginary part is supposed to be last. All right, let's do one more like that. 2 plus I times 2 minus 3i. Make sure you don't make any little mistakes. Math rewards careful people. Now, I told you last time that it's actually better to think of this as distributing than FOIL, because then it works when you have 3 parts times 2 parts. But FOIL is okay. It's not illegal. It just won't work on harder problems. So I'm going to start with this 2 here and do 2 times 2 is 4. And then this 2 times the -3i is -6i. And then this is, well, I should do it this way. Plus 2i, and last but not least, minus 3i squared. And then I got to know 2 things. Those can go together. That was an I. And then that makes -4i. And that is -1. Compare answers with the kid next to you. See if you got the same exact thing. I think some of you messed this up. We'll find out. That is -3 times -1, which makes +3 plus the 4, 7 minus 4i. Raise your hand if you had 7 minus 4i. Okay, that's most of you. If you goofed it up, try to figure out where you goofed it up. And maybe I goofed it up, but I don't think so. A lot of people disagreed with me on that one. Because the blue circled area is +3. You put it with the 4 and you get 7. Okay. All right. Then I showed you that I to the 17th would be this, and I to the 3rd would be that. Try I to the 7th, please. So take a second and figure out what I to the 7th is. Hint, it's a bunch of I squareds. And then sometimes you have to throw in another I. I did make it pretty clear that we don't start class with things like corrections, but later in the hour, when it is work time, it's a great day for doing corrections. You can have your test back, you can do the corrections. If you already did the corrections, you have to staple them to your test. So we can deal with that in the last And during the work time, which is sometimes only 10 minutes, sometimes it's more like 20. I think today will be one of those, like you get a little more time to work kind of days. All right, this should have been I squared times another I squared times another I squared, and that'd be I to the 6th, and then one more I. That would make -1 times -1 times -1 times I, and that means -1I, or just -I. Raise your hand if you had that one right. Cool. Okay, that's a review. Now we're all caught up. And now, here is a typical question from today. Solve. Now, you've gotten smarter about how to use I. So, get smarter about how to write the answer for this. And you can't just say it's impossible. It is possible if you use imaginary numbers. And there's a classic trap that a lot of people are going to fall into. See, a lot of people get to x squared equals -1, and they're like, okay, well, that's, I'm going to square root both sides, and x equals a square root, and x equals I. Sweet. Wrong. It's very easy to get that wrong. Who knows the secret? How about this? Who knows the right answer? 0 people. Interesting. Yes?
Is it 1I?
Nope, it's a good guess. Nope. 1I is the same as I, and that isn't any better. Carter. So you think the answer is -I? All right, good guess. You're kind of right, but you're kind of wrong. Let me see, who raised their hand for a second? Mia was first.
Is it I squared?
It is not I squared. Thank you very much for giving that a shot. Olivia.
Is it plus or minus I?
Yes. Plus I and minus I. Because I am convinced that the reason you guys all forgot that is because when you were taught this, let's go back to an easy one, x squared equals 16. That a lot of people were taught this. Tell me if you were one of them. The square root of x squared is x. They just acted like that was x, and it's not. But they just acted like that was x, and then they said it was plus and minus 4. If you were taught that way, I apologize on behalf of math teachers. That's not how they should have taught it to you. I get it. I get the teacher was trying to do a shortcut, and that is kind of right. The answers are 4 and -4. But the problem is they made you think that when you took the square root of x squared that you just get x, and you don't. Let's talk through that. When you take the square root of x, you get the absolute value of x. I can prove it to you. I will in a second. And when you get the square root of 16, again, that method that they taught you makes you think there's 2 answers to it, and there isn't. The square root of 16 is just 4. That symbol is called the principal square root symbol, and that means give me the positive. Only a positive answer is okay. The answer is 4. You can't have a square root come out to a negative. You should know that. Okay, so let me prove this part. I'm going to be your graphing calculator. The square root of x squared, if that really is x, if this, when you square root x squared, if that answer is really x, would you agree then it would look like y equals x, which would be a graph that looks like this. That's the graph of y equals x. What I say it is the square root of x squared is the absolute value of x. And if you graph this right here, you graph the square root of x squared, your answer will look like that. And do you agree that that's the absolute value graph? Okay, so there's a problem. Literally nobody in the class, until I said you were all wrong, and then we got some ideas, nobody got this right. And I think it's because you think when you square root x squared that you should just get x, and you don't. You get the absolute value of x. And then do you remember you break it into two things? You split this into x equals 4 and x equals -4. So there are two answers to the question. But I think you didn't know that this is the absolute value of x. And the absolute values always have two answers when there's a variable in there. If you don't get why, it's because you could either have 4 in here or -4 in here, and it would work. All right, so from now on, when you solve something like this, you need to remember square root, absolute value of x equals 5. And then you split it into two parts. I will warn you, this year, do you get that there's 4 hard problems on each test? They're called the R3s. And if you get 3 out of 4 of those wrong, you're going to get a C on your test. You pretty much bombed your test, right? If you're on the 4 hard problems. That's where it's all about in this honors class. If you haven't figured this out yet, almost everybody gets the easy questions right. If you get the easy questions wrong, you just failed the whole test. But everybody pretty much gets, maybe you get 1 wrong in the easy part. That's the 8 easy questions at the beginning. It's all about the 4 hard questions. And if you can get 3 out of 4 of the hard questions right, you're going to get an A. So it's all about the hard questions. All right, 4 times this year, 4 times in the middle of a test, not just this test that's coming up, but future tests. 4 times this year, there's going to be a question just like this, where it's going to come down to x squared equals 144. And you're going to have many chances to screw this up by going x equals 12. Wrong, because it's got 2 answers. That's going to happen a lot. So the final answer really is this: square root, absolute value of x, because that's what this is. And that leads you to know there's 2 answers: x equals 12, x equals -12. All right. It's not just my preferred way of teaching it, it's that the other way is wrong. The other way is teaching you things that are wrong. It tells you that this has 2 answers, which it doesn't. And it doesn't teach you that that has 2 answers, because it does. All right, so we're back to this, and I had gotten to here, and I had said, how many of you think that's it? And like pretty much everybody thought that was it. But the actual answer was absolute value of x is I. So there's 2 answers, x equals I and x equals -I. It's going to be all over today's homework, which of course means on the test, it'll for sure be on the test. You've got to remember that there's 2 answers and how to do it. Okay. That's the big point for today. So now let's see if you can actually do one of these without my help. That's page 2 of the notes. Find it, do it like I showed you, so you don't by accident forget an answer. All right, should have subtracted 4 from both sides. Should have had x squared equals -4. And before you get all excited and just go, ooh, I know there's an I in it, you got to follow the steps. Did you square root both sides? Good. Did you know this was absolute value of x? Did you get 2 answers for this? No. You get 2 answers because of this. So what is the square root of -4? Ooh, that seems impossible, almost imaginary. What did you get? Sasa. Or would you rather use your other name? Whatever. That's what it says on here.
I'll use Vanessa.
Okay, Vanessa. If you want that officially changed, there's a form we can do. Go ahead.
-2i and 2i.
All right, you're close. The square root of this is only one thing. And I'm convinced that when people taught you this and they told you square root, and square root of 16 is 2 things, plus and minus 4, they taught you wrong. Because that's what's making you think there's 2 answers to this. There's only one answer for that.
Oh, I thought, okay.
Just one answer. What is it?
2i.
2i. Good. Now that there's an absolute value here, we can get the two answers, which are x equals this and x equals that, which is
Negative 2i.
negative 2i and 2i. Raise your hand if you had those two answers. Okay, awesome. All right, so that was a big deal. But they get more complicated at first. But honestly, from here, it's just like, oh, there's one more step. You just add one more step, then they add another step. So what do you think the first step is here? A violet. Just step one.
Squaring of x plus 2.
That's a good guess, but no, you don't have to do that. Instead, I'm going to remind you PEMDAS is a big deal in math, right? But when you're solving equations, you're doing PEMDAS backwards. So, would you agree you add or subtract first? Let me give you an easier one. You know, like let's say it was this. Would you agree if here we would start by subtracting 3? And then we would get rid of the multiply later. It's because you're doing PEMDAS backwards. All right, so back to this. So, is there any add or subtracts we could do? And I think by now you probably know. What is it? Minus 36. Now, what you were going to do would have worked. It would have just been really slow, and at the end, you would have had to try to factor it, and then you'd be like, how do I factor this? And it wouldn't factor because it's imaginary. And then you'd have to use a quadratic formula, which has 16 parts. So this way I'm showing you is definitely faster than the way you were going to do it. Square root, only one answer to that square root, which is 6i. This has absolute value bars around the x plus 2. This was on the basic 20, or the first 20. Do you remember how to do this? X plus 2 equals 6i, and x plus 2 equals negative 6i. This is one of those moments where those basic 20 things come in handy, because if you never knew this, my basic 20 might have, if you were smart, you went and watched the video on this and you remembered, oh yeah, that's how you do absolute values, you break them into two things. All right. So then we just have to solve this by minus 2, and minus 2. And now I get x equals, what's supposed to be first? The negative 2 or the 6i? Negative 2. I know it's picky, but hey, a lot of things are picky in the real world. Negative 2 minus 6i. Some of you on the last Schoology quiz were like, why is there two answer blanks? Because you were trying to say like plus and minus 6. Well, you got to do it once with plus and once with minus. See? This, technically, let's see if you're smart enough to handle this. Technically, this was negative 2 plus and minus 6i. Do you get this is the plus I and this is, or sorry, plus 6i and this is the minus 6i? See what I mean? Now, is this a better way to write it? Not really. It's just a different way to write it. So you got this answer from this and this answer from that. Okay. Next one. This time, there's nothing you can add or subtract. Like, if you think we can add 2 to both sides, yeah, no. So if I'm going to go through PEMDAS, I ask myself, can I add or subtract? No, those guys are stuck on the inside. They're stuck in jail here. They can't come out. You can't just like add 2 to both sides. That will not work. So if I'm doing PEMDAS, I cannot do add or subtract. I'm going up to multiply and divide. Is there anything I got to multiply or divide on both sides? Yes. And you would divide both sides by negative 3. And I know some of you are like, but I don't want to multiply it all the way out. And you could. And then you'd have to get the quadratic formula at the end. So after 8 steps, then you could start a 16-part formula. This will be way faster. Ooh, 48 divided by 3 is kind of gross. Help me. Negative 16 sounds believable. I'm going to times it by 3 in my head just to make sure it actually makes 48. 30, 48. Yup. Nice job. Negative 16. Mr. Zapp, next step.
Square root.
Correct. Really critical moment, Seiji. I've been teaching you about this. Don't screw up this side, don't screw up that side. What should I put?
Absolute value x minus 2
Perfect.
and negative, no, 4i.
4i. You don't have two answers at that point. You just have 4i. Then splits into 2. X minus 2 is 4i. X minus 2 is negative 4i. Mark, final answer. X equals this and X equals that. What did you get?
X equals 2 plus 4i, and then x equals 2 minus 4i.
You got it. Do you get how our answers commonly have I in them now? For extra, I'm impressed points. What kind of a number is that? Don't say imaginary because you're wrong. No. Not irrational.
Complex.
Who said that? Yes, they are complex numbers. You know what the title of this chapter is? Complex numbers. Because they have a real part and an imaginary part. If it was just imaginary, you could call it imaginary. But see, this has 2 plus 4i. That's not just imaginary. The real part and the imaginary part together make a complex number. Okay, so these are called complex numbers. Because you got the real part and the imaginary part. And there was your final answer. Get to this page. Ooh, looks like it's telling us we're ready to do the homework. Yay. And a nice cringy math joke. Irony as in iron and, okay. Complex because you got real and imaginary part. Life is complex. This is your worksheet. If I ask you to nominate which one to torch, you're going to tell me I have to get rid of the last one, number 12. So I'm just going to pick what is considered a lucky number in China. Can anybody name it? 8. 8 is considered very fortunate in China. And I know some of you guys actually took Chinese and maybe even learned it like in elementary school all the way through. Can anybody say properly the name for 8 in Chinese? Okay. And is there another word that you know that is kind of means like fortunate that sounds like that? All right. The way I think I understand it is if you say, is it as simple as ba? Okay. If I say it with a different inflection, that it means something different. Is that true if you say like ba as opposed to just ba? Does that mean different things? Yeah. So when you're speaking Chinese, if you just say it with a little different inflection, it means one thing. So the point, I'm trying to teach you two things at once. We're skipping number 8, and that, yes, because I was trying to teach you something about the number 8. It's actually, in China, in some cities at least, they allow you to buy your license plates and auction them off. It's kind of smart, because then people are willing, that are super rich, are willing to pay tons of money for a very fortunate license plate. And so like the ultimate license plate would be like 88888, because it's all 8s, and like people spend a ton of money to be the person who has the license plate that's all 8s, because it's like supposed to be really good luck. All right, so anyway, we're skipping number 8. Let's do number 1 together. Would you agree we subtract 1 from both sides? And you now are much smarter. A minute ago, you would have probably thought that when you square root this, that this would just be x, and now you know its absolute value of x. And that will then lead you to know that there's 2 answers because of the split that happens here. All right. I think this will be a nice, easy one for you. You got a lot of work time today. Like I said, if you really want to, you could come up and get your old test to do corrections or staple your corrections to it. And that's all I got for you for today.